Hello class. Today we're looking at solving absolute value equations and solving absolute value inequalities. The process for both is about the same. You have to watch though with the inequalities and you'll see why here in a minute. So to solve an absolute value equation, and that would look like the absolute value equals something, okay? Where A represents a variable expression. So A can be an expression inside the absolute value, that's fine. And where B has to be greater than 0. So it has to be this absolute value has to equal something greater than 0. Why is that? Well, remember, absolute values are always positive numbers. They're always the distance from 0. So in order to solve these, you want to isolate the absolute value by itself, and then you break it down into two equations because you're going to have two possible answers for this. You break it down into the positive A equals the positive B, and then you also break it down into A equals negative B. So you isolate the absolute value, and then you break it down into the positive and the negative. When solving absolute value inequalities, the first two steps are the same. You isolate the absolute value and then you break it down. However, when you break it down, you're going to break it down into the positive and the negative. But when you break it down to the negative, just like when we divide or multiply both sides of an inequality by a negative number, you're going to have to flip that inequality sign and place the negative there. Now, if this is a less than absolute value, and notice how you can write it with the compound inequality, or you can write it with the word and, join it. They both mean the same thing. A is less than B, and A is greater than negative B. That's an and situation. That's with the less than inequalities. When you're solving absolute values with greater than, you're going to have to break it down again into the positive and the negative, flipping the inequality sign, except now you have the or between them. A good way to remember this is less than, and, less than, great or, great or. So less than, great or. That's how you can remember the difference as to whether they're going to be joined by an and or an or. Let's look at a few examples and hopefully we'll clarify some of these instructions here. Our first example, we are looking at the absolute value of A minus 3 equals 5. Now, if we go back to our notes, notice you have the absolute value equals B. You have to have the absolute value by itself in order before you can break it down into the positive and negative. So if we look at this first equation here, we have the absolute value of A minus 3 equals 5. In this case, the absolute value is not isolated. So we have to get rid of the minus 3, and we can undo subtracting 3 by adding 3 to both sides. We're then left with the absolute value of A is equal to 8. We then want to break it down into the positive and negative. A equals 8 and A equals negative 8. And that's it. So when you have an equation, the absolute value of A minus 3 equals 5, think about this. If I put an 8 in here and take the absolute value of it, subtract 3, I get 5. If I take the absolute value of negative 8, minus 3 equals 5. In that case, it works as well. Now let's move on to a second example. Now notice here we have the absolute value isolated. The absolute value is by itself, and that's going to equal 9. So because we have the absolute value isolated, we can break it down into its positive and negative. So you break it down into its positive and its negative. Positive and negative. So we have 3c minus 6 equals positive 9. And then we have 3c minus 6 equals negative 9. Please take the time to work these equations out and solve them. Not only is it good practice, but I noticed on some of your quizzes you're making very small mistakes with your solving of equations because you're skipping steps and trying to do them in your head. So we get c equals 5 on this side. Over here with the negative, again, we're going to add 6. And notice the procedures for solving both of these are going to be the same, but the outcome is different because we have the negative on the right side of the equation over here. So we have negative 3, divide both sides by 3, and we get c equals negative 1. So we have c equals 5 or negative 1. And we could plug in either number here and we would still get the 9 as the solution. Moving on to example 3. Now we have an inequality, okay? So the first thing you want to check is the same thing you would check if you had an absolute value equation. Is the absolute value isolated on one side of the equation or inequality? And yes, it is. So now we can break it down into the positive and the negative. So we have y minus 5 is less than or equal to 2. That's the positive root there. Then we have y minus 5 is greater than or equal to negative 2. Remember, just like when we're dividing both sides by a negative or multiplying by a negative, we have to flip our inequality sign and we're left with a negative 2. Okay? Now we can go ahead and solve the inequalities. We're going to add 5 to both sides. I'm left with y is less than or equal to 7. And we're going to add 5 to both sides here. And we get y is greater than or equal to 3. Now, let's go back to our original problem here. We have the absolute value is less than. What will these two inequalities be joined by? Less than and. Hopefully you said and there. Great job. These two inequalities are going to be joined by and. Just like we talked about yesterday, when you have two inequalities that are joined by an and, you're looking for the overlap. So here we have 3, and here we have 7. And we'll just put my 0 on there for good measure. Going to have a closed circle on the 3. And that's going to be going to y is greater, so that's going to the right. And we have a closed circle on the 7, and that is less than, so it's going to the left. So our solution is then going to be between 3 and 7. That's the and part. That's the overlap. So one possible number that would make this absolute value inequality true would be 5. Just to check, 5 minus 5 is 0. And the absolute value of 0 is 0. And that is less than or equal to 2. So we just did a quick check there, and we're ready to move on to our next example. A manufacturer has the ideal diameter of a piston for one type of car to be 88 millimeters. The actual diameter can vary from the ideal by at most 0.007 millimeters. So what we want to do here is we want to write our own inequality, and we're going to write this as an absolute value inequality. We're going to let D equal the actual diameter in millimeters of the piston. Notice how we've defined our variable here. It's very important that you are precise in the the description of your variable. So we are going to take the absolute value of the actual, and we're going to subtract 88 from that. And then that is going to have to be less than or equal to, at most, 0.007. So now, because we have an absolute value, we are going, and it's isolated, we're going to break it down into the positive and negative. So here's my pen, come on, the diameter minus 88.000 must be less than or equal to 0.0077. My eraser here. Or less than, and, okay, these are going to be joined by an and, it's less than, the diameter minus 88 is going to be greater than or equal to negative 0.007. So then we can add 88 to both sides here and here, and we're left with a diameter that has to be less than or equal to 88.007. And then over here, if we add 88 to both sides, you're left with the diameter must be greater than or equal to 87.993. Okay, we can write a compound inequality here to show that the diameter is going to be less than or equal to 88.007, and it's going to be greater than or equal to 87.993. So if we graph that inequality, there's my, okay, we're going to have, this is 88.993. I'm sorry, this is 87 here, and that's 88 here. And our diameter is going to be between those distances. It's an and situation again, because you have the less than sign between them. Okay, so we have the less than sign there. So it's an and situation, which means it has to fit both criteria of being less than 88.007 and it has to be greater than 87.993. A few things to think about. Just like when you had compound inequalities and they were an and situation and they didn't overlap, or an or situation in which they came together. Think about what type of solutions you would get for both of those. I have a feeling you might run into them in the quick checks coming up in class tomorrow. You may need to watch this again a second time. You may do so at any time. You will have a Chapter 4 test on this material next Wednesday, right before conferences. Good luck. See me with questions. I'm sure you'll have lots.